So as I said, tonight's presentation is What's Up with Helium. We'll be discussing where it comes from, how it's mined, how it's purified, how it's distributed, what are all the uses for it. And then once we can't find it easily here on Earth, where else do we go to find it? But first, the news. So I was watching it before I started the session tonight. The Inspiration 4 Dragon capsule had landed in the Atlantic Ocean, and they were in the process of connecting the straps to hoist it up onto the boat so that they could pull the astronauts out and then give them a physician check and then allow them to speak to the public. So I think by now all the media has already gotten their fill of it and gone on to other things, but they definitely are astronauts. So if there's any question about, altitudes and whether it's 65 or 70, they were actually in orbit for 3 days at an altitude higher than the International Space Station, higher than the Hubble Space Telescope. I guess that's just to prove the point. Or maybe that was the first easiest short duration orbital slot that the FAA would approve for SpaceX. So commercial, genuine astronauts are now a thing.
Did you see the launch?
Yes, I didn't see the launch outside. I saw the launch on YouTube on a live feed from SpaceX.
I watched it out my back door, and of course, I saw the orange flame up to a certain height. Yep. And then when it got to a certain altitude, it must have hit layers of clouds or something, because these spectacular, huge plumes of, they looked like angel wings,
yep,
were coming off the top and bottom of not only the ship, but the booster rocket as well. It was that's a
humidity inversion. Yep. And what it's doing is that's very cold, moist air that suddenly has an injection of high temperature, so it produces light from it. But yeah, that was an unusual effect. I was looking at all the fog around the launch pad and going, are they really going to launch? And they said, well, we don't have any clouds. And I was thinking, yeah, except for the ones that are at the launch pad. But they launched successfully through them like it was nothing. So they're up. They were there for 3 days. I saw a couple of stills of one of them. I think it was the doctor poking her head up into the cupola to get a look out into space. I think that's just another, hey, look what we can do. Or, we can do better than those other two groups. One of the side effects of that was they couldn't take the cupola off when the capsule landed in the Atlantic Ocean. They had to use the original side door to get the astronauts out, which is the same door they went in on. The reason why that was a little iffy is that when you're bobbing around in the Atlantic, if the ocean happens to be a little rough, the last time they opened a door like that, I think the capsule sank to the bottom of the Atlantic, and they recovered it about 50 years later. Remember Grissom's capsule, Freedom 7?
Yeah, full of water, yeah.
Yeah.
I could be mistaken, but it looked like they might have pulled the capsule onto the ship before opening that door.
Yes, because they didn't want to take the liability should, waves suddenly come up and water go into the capsule, because the capsule's reusable.
Yep.
Salt water is not good for it. Oh, and I think it was Liberty 7 was the Grissom's capsule that sank. I don't think it was Freedom 7. I think Freedom 7 was John Glenn.
They used to pick it up from the ocean by helicopter, and it was too heavy because it was full of water.
Yes. I actually got to see the video of that years ago, and you can see that the helicopter is trying desperately, and then somebody gives it the, no, just don't, and they pull the handle, and the capsule goes bloop into the ocean, and the helicopter goes up.
Yeah.
He was pulling heavy.
He tried.
Mm-hmm. So these are civilians that went out. Now, how do the astronauts that are not the civilians feel about this, do you think?
Well, the astronauts that work for NASA aren't complaining because NASA, uses SpaceX Falcon 9 capsules and the exact same Crew Dragon capsule to put the NASA astronauts up. So the only distinction is they're all astronauts. This is weird. The only ones that orbit the Earth that are not astronauts are cosmonauts. Those are the Russians. The orbital people from China, those are called astronauts as well, even though they use a different word in Chinese or Mandarin to say what their actual name is. But they're referred to as astronauts. If you think of it as, say, Olympics, anybody that participates in the Olympics is supposed to not be a professional athlete. They can be an amateur athlete. But they don't want to call these folks amateur astronauts because it's a commercial flight. They paid money to be on it. So they're not getting paid for it, but they are paying money for it. So it's kind of like Dwarf Planet. You come up with new information that requires you to change your definition. And when you change the definition, you try and not step on too many toes. So I'm okay with these folks being called astronauts. Unlike those that flew on Blue Origin, these folks actually went through 6 weeks worth of training, and they had to actually designate who would be the mission commander and who would be the mission pilot. So these people had official, rank and responsibilities. They weren't just, flotsam on board the capsule.
Thank you.
Shape of things to come. And speaking of the Chinese, did you know the Chinese have their own space station, different from ISS? And did you know that they had astronauts up there for the last 90 days? And they just came back? I found it kind of strange that there wasn't a whole lot of news in the media regarding this. I had to go out to Space Flight Now, sort of a techie, space astronaut kind of website to find it. But since they were up there for 90 days, notice, I guess their space station, they don't have a treadmill on it. So in the 90 days, they lost enough muscle tone that here they are taking their interview immediately adjacent to the capsule they came back in. Have to have the Chinese flag poked in the ground there. They have to have the red tape cordoning off the area. But they're all happy with smiles and answering questions and such, but they had to sit in chairs because they were a bit unsteady on their feet.
Wow.
So the first question I had was, so there were 3 on board the Chinese space station, and the 3 came back all at once. Who's manning the ship? Who's on board the Chinese space station? I think the answer is currently nobody. So nobody's flying the helm.
So it's on autopilot?
Well, I mean, it's orbiting, and the orbit's not going to decay for at least a year or so. So, it flies on its own. There's no helm. There's no, gears or joystick or anything. It orbits. And something hit Jupiter again.
Well, we have some controls from the Earth, right?
The Chinese space station is orbiting the Earth. It's in a low Earth orbit of a couple of 100 miles.
I mean, do we have some? We have some kind of controls up to the space station, the other space station, not the Chinese one, but the other one. So
it's an international planet. We don't have any skin in that game. Why would we have any control over what another nation is doing? It's not like it's nuclear weapons or anything.
No, I'm just thinking that we communicate, and there's some like the rover. I mean, we communicate with rover out there in outer space and have it do things. Can't we communicate with? You know what I'm saying? Maybe not.
The Chinese space station is in communication with the Chinese space agency on the ground, using their own network of satellite dishes.
Okay.
They do not use the NASA Deep Space Network for it, and that leads to some side effects, which are they can't always be in contact with their space station. There are several hours per day that they don't have any contact because, we have a giant dish down in Australia and one in Spain and one in Southern California, but we don't have one in Russia. But then we don't need one because we've got our 120-degree separation covered between Australia and Spain. But China does not have their own deep space network ground station in the continental United States. They actually have one in Patagonia, down in the far southern end of South America. But their space station is at a different orbital elevation such that it can't always be reached from there. So,
they're okay with that.
That's what they've got to work with. And I don't know that they've come over and asked us to, use communication time on the Deep Space Network. So
maybe they ran into trouble, but maybe you're saying it takes a year to decay. Maybe they're not worried about it.
If they got into trouble, I would think that we would offer our services.
Yeah.
As to what we could do, I don't know. It would not take our largest radio antennas. Our smaller antennas at the Deep Space Network stations could easily reach orbit, no problem. But it does take a several meter sized dish to communicate up to a space station. And the antenna has to constantly be moving to track the space station.
I wonder what it does, whether it's doing experiments.
Oh, they were doing, the Chinese astronauts said that they were doing experiments on board their space station. As to what those experiments were, I don't know.
Yeah, and whether or not it's supplied for future Chinese astronauts.
I think they put it up there for the long term. I don't think they put it up there short term. I think the next time they go up there, they're probably going to add a new module to it, do a couple of spacewalks to hook it all up. Okay, something hit Jupiter on the 13th of September. An amateur astrophotographer just happened to be capturing some snaps of Jupiter and saw big white dot go boom on Jupiter. And so for Jupiter, this was like a gnat hitting it, like no big deal. If something that many megatons hit the Earth, it might be another life-ending event.
For the Shoemaker event, we had a long advance notice about it.
Yes.
There was no advance notice about this?
No. The only notice that was received was when this guy took a picture and then he circulated it and somebody picked it up and went, I think you've seen something.
Yeah.
Now, we do have a spacecraft in orbit around Jupiter. It's called Juno. But if it happened to be on the backside when this thing hit on the front side, if there are such things, then we wouldn't have picked it up because we weren't looking at the time. As they often say, there are more amateurs imaging than all of the military and professional astronomy going on across the whole planet. So the amateurs do have a leg up on how often they're looking, because they're not looking based upon a schedule, based upon funding, or based upon unique resources like observatories and large dish antennas for communication. They're just out in someplace dark or in their backyard snapping photos. Now I'm sure that there will be a dark spot on Jupiter for a couple of days as this all settles down, but that's many megatons worth of force that just went boom on Jupiter. But Jupiter is fine. It never actually made it that far down into the atmosphere. Apparently it was going so fast that the implication is it was either a comet or an asteroid.
Is Jupiter just gas?
No, it was something that was solid. It was going so fast that the force of impact with the upper atmosphere caused it to detonate.
Yeah, but
And,
Jupiter itself is not solid, is it?
the core of Jupiter is believed to be solid, but there's many thousands of miles of gas at varying levels of pressure before you ever get to the core. Okay, this one I found a little disheartening. We'll see what NASA says. I had not stopped to think about this, but Mars has seasons. And the seasons on Mars, you can go from winter to spring and summer. When you're in winter, the atmosphere is denser. And when you're in summer, the atmosphere is thinner. The Mars Ingenuity helicopter was designed to deal with the thin atmosphere of Mars, but not the apparent summertime thinner atmosphere of Mars. So they're now trying to say that if they attempt to fly Ingenuity on a regular basis, it's going to become more and more difficult because the autonomous flight program has to make the helicopter props spin even faster, which consumes more of its 5-minute flight duration. So they're trying to figure out, should we fly it or not? Okay, let's just say they decide for the next 3 months they're not going to fly Ingenuity. If they happen to drive Perseverance beyond radio range to Ingenuity, Ingenuity is only autonomous because of the periodic communication with Earth by way of Perseverance. So if Perseverance drives too far away and Ingenuity can no longer indirectly reach Mother Earth, it's just going to sit there. So if Perseverance drives away and gets out of range, it may be mission over for the currently operational Ingenuity, unless Perseverance drives back over closer to it where they can regain contact with it. So we'll see how NASA figures this out. It would be sad, but Ingenuity has already gone way beyond what they initially envisioned for it. So it's done more than its fair share of its intended mission, some additional science, and some pathfinding for Perseverance. So let's see how much empathy NASA has for Ingenuity.
Well, I thought you said it was a 3-month period and that they were going to start up again in 3 months. Is that a problem?
Well, if in the meantime, Perseverance, which is powered by nuclear decay and has no shortage of energy, drives, 10 miles away from Ingenuity, they'll lose contact with Ingenuity because it's just a short-range radio transmitter.
But I mean, can't they move it closer when the season comes in?
Well, that's something they'd have to do. Are they going to change Perseverance's mission objectives in order to go back and bring Ingenuity forward? In other words, for Ingenuity to play catch up. So I don't know. Let's see what NASA does. Ingenuity has gone far further and done more than they originally envisioned. It's definitely done more than proof of concept. It's done, real observational science. So they could sort of kick it to the curb and go, well, if anything ever comes back that way, it'll be sitting there waiting for commands until, the dust storm comes by and puts dust all over its solar panel. And, we have another Spirit Opportunity event where it's just not going to start up ever again. So let's see what NASA does.
Nobody else could hijack it, could they?
Not to my knowledge, because it's too far away for an Earth radio signal to get directly to it. Because remember, it has a very small battery, so it doesn't have a high-power transmitter receiver on board the helicopter. So it can reach Perseverance, but something would have to be within, let's say, 500 feet of it in order to talk to it.
No, I'm thinking like the Chinese or Russia or somebody gets up to Mars. Now they're on Mars and we left it sitting somewhere.
Oh, yeah.
Did somebody take it over?
Oh, that's definitely a possibility because it's not encrypted communication.
That's what I'm thinking. Okay, I think we should go after it. Okay, that's
Here's the funny thing. When they dropped Ingenuity off the bottom of Perseverance, that was it. They can't pick it up again. Because remember, it did a free fall of about 18 inches from the bottom of Perseverance. So there's no little hook to pick it back up again and roam around with it. Now, I guess that they might, make Ingenuity helicopter fly up and land on top of Perseverance. There's some space up there. If it landed on top of Perseverance and it didn't, there was no jeopardy of it damaging Perseverance in doing so. Perseverance could ride piggyback style. I mean, Ingenuity could ride piggyback style on top of Mother Perseverance. So then they could fly it again in the future whenever they wanted to.
sounds good.
I think it's worth considering. Okay. And occasionally I find stuff on physics.org or phys.org that is, science yet to come, something that they just realized is possible, and now they have to improve it to make it industrial scale. But the reason why this grabbed my attention was it's nanoscale metamaterials. We're always looking for ways to do catalytic conversion of water into hydrogen and oxygen for various things, rocket fuel, to power automobiles, to run turbines for power plants. You want that hydrogen. Well, they found out that if you get down to the billionths of a meter, and you coat an iron sulfur nanocrystal with nickel or cobalt, that it makes it more receptive to splitting water into hydrogen and oxygen. It improves the efficiency of it. But they're at the nanoscale level, so it's, until they scale it up a bit, it's not going to be an industrial thing. But it's just another example of, well, if they just sort of mix these chemicals up at large scale, probably wouldn't get the same effect. But by using ions and coating things at the nanoscale level, you get these unique physics effects that are beneficial. So just learn how to scale that stuff up. At least they wouldn't have to use platinum or iridium, which are very expensive. And Helen and I attended the online training for the James Webb Space Telescope events. Ours will be on December 11th. The launch is on December 18th. I have a new subject matter expert that's been assigned. His name is Will. He works at the Space Telescope Science Institute. He is a general instrument assistance individual. So he understands the spacecraft. He understands all the various instruments. But he also has prior experience with being on board and doing science on this thing called SOFIA. So I think maybe he and Helen will have some things to commiserate about. And then a follow-up from last week. Can you see the inverted rhino? Yes, they were flying a rhinoceros by a helicopter upside down by its legs. They put these, harness on the bottom side. You can see the harness starts just where the body ends and the legs begin, and then there's straps that go up the sides of the legs and attach on, and then the 3-point harness comes up from that and it goes to a 1-point connection to the strap to the helicopter. And yes, the Ig Nobel prizes did take place. They took place on September 9th. So even last week we missed them. And one of the prize winners was rhino transport, or inverted rhinos. And I dug into it and said, well, why don't they just build a cage and pin the rhino inside the cage and fly the rhino vertically? Apparently the rhino would freak out. So what they do is they sedate the rhino. Given the massive size of the body of a rhino, and given how long they have to fly it to its relocation destination, normal sedatives would wear off and the rhino would go berserker. So what they do is they give the rhinoceros a heavy dose of opioids. Yeah, opioids, which is the reason why they were concerned about blood oxygen levels. And they found that when the rhino is right side up and you put the straps underneath its body, so it sort of goes underneath its armpits and leg pits, and then you hold it vertically, the straps tend to reduce the ability for the rhino to breathe, which reduces its blood oxygen level. And since its blood oxygen level is already reduced by the opioids, there's a concern for the safety of the rhino. Now, the rhino is completely oblivious to being inverted. Its blood oxygen level apparently does not drop to a low level. So from what I can tell, it's a safer way than with straps under the belly way of transporting these unconscious rhinos. So I'll give them a pass at this point, but I still think maybe you should do a CT scan, an MRI, do an MRI of the rhino before and after and see if all the organs shifted upwards in its body. But that was the ignobles.
I wonder how many of them they're doing.
They did a research project. Let's see if I can flip down here. Transportation. It's on Bio1 Complete. Bio1 is apparently a website where they publish these things. It looks like you have to have an account and maybe pay for it, but otherwise you can get the abstract. The pulmonary and metabolic effects of suspension by the feet compared with lateral recumbency in immobilized black rhinoceros.
I was just
captured by aerial darting. So apparently you need two helicopters. The first helicopter flies overhead and you dart it, so you anesthetize it, and then you can approach it. You give it a heavy dose of opioids to keep it knocked out for hours, and then you put in the straps and you suspend it upside down. And then you fly it to the destination, and then you give it something to bring it back awake, and it's fine. Where they actually get into the specificity of the entitled and in blood CO2 levels, and they check for both the postures. But it doesn't say vertical. You know what it is? The opioid so sedates the rhino that it can no longer stand up, so it would fall over. So that's why they didn't, check it vertically. I guess you could make
a reason to move these rhinos in the first place before they decided
they're endangered. Yeah. You have to move. You have to move them from areas where poachers are getting them to areas that are national preserves where they're less likely to get attacked by the poachers.
Yeah, they should dart the poachers.
That's very true, Joe.
I think they ought to dart the poachers, but not so much that they're unconscious, and then hang them upside down by their feet by helicopters and fly them to new destinations.
Exactly.
Yes.
They're lighter, it'd be easier.
You could fly a bunch of them with one helicopter. Well, they are carrying rifles. So if at the national preserve where these rhinos are going, the poachers did enter the preserve to kill the rhinos, the poachers themselves would likely be certainly caught, if not killed. So that was my rhino follow-up to the ignobles.
Thank you.
I'm not going to start this, but yes, we are, as far as I can tell from looking at the other computer display, we are still live on Facebook Live. But without Helen promoting it, I guess the only person that's on our Facebook Live connection is me on the other computer just to monitor things. So any other news items?
I have heard that the people at the Large Hadron Collider in CERN have found another particle.
Oh.
Tetra Quark.
Tetra Quark.
Yeah, it's supposed to last a long time, and it's been has been proven.
Well, let's see if I can find out something about that. Tetra Quark. Sounds like a funny take on somebody from Deep Space Nine.
No, I was reading about it.
Tetra Quark, yeah. So this would be a new kind of quark?
So I've been told.
Okay, a tetra quark in particle physics is an exotic meson composed of 4 valence quarks. So 4 quarks coming together forming a meson. Let's see if I can see that in the picture. Muons, no, call it mesons. Leptons, quarks, bosons. I'm going to take a note. Tetra Quark. I'll explore it and we'll find out about it during next week's news session.
Great. Okay.
Thanks, Joe.
If I catch a few of them, I'll bring them in.
Well, my thought is, how easy is it to make them? How long do they last?
Yeah.
And is this going to change the standard model of particle physics in any way? Because that's almost sacred ground for some scientists. They kind of think, they're a scientist, but they don't want science to change anything that they thought they had a good bead on.
Yeah.
And if everybody that's a scientist thought that way, we wouldn't have science.
That's right. Or penicillin.
Yes. Sometimes you get lucky with accidents. So tonight's presentation is What's Up with Helium? This is something that Diane had said, take a look at it, learn all about it. So that's what we're going to do. I'm sure everybody knows what helium is. It's a light gas that's used to loft balloons and such and make people's voices go funny. But here's the details on helium. It's element number 2 on the periodic table. It's named after Helios, the Greek god of the sun. And we'll get into why that would be. Normal state is 2 protons, 2 neutrons, 2 electrons. It's a monatomic noble gas. Now what that means is it's in this section on the periodic table of elements called noble gases. And it's monatomic. If you think of oxygen or hydrogen, they all like to be diatomic. They like to say, I'm O2 or I'm H2. But helium's like, no, I'm fine all by myself. So it's single atom floating around. At room temperature, it is inert, doesn't mix well with others. Odorless, it's odorless in that if it doesn't chemically interact with other things, how would you know how it smells? So it being inert contributes to its odorless, tasteless, colorless, non-toxic state. Think about that for a moment. If something does not interact from a chemical perspective, how would you smell it? How would you see it? And it would not be toxic to you because it doesn't interact with you. So it's a liquid when cooled to 4.5 Kelvin or minus 452.2 degrees Fahrenheit. If you cool it to near 0 Kelvin, it becomes a superfluid. This is also known as a Bose-Einstein condensate. And what that means is this liquid has near nil friction. So if you had a little sort of droplet cup holder of liquid helium and you tilt it so that some of the liquid curls up over the edge of the cup, and then you right it back up again, all your liquid helium would come out of the container. It would literally crawl up the side and off onto the surface below it. And the reason why is, as a Bose-Einstein condensate, it doesn't have any resistance from a friction perspective to moving up over the side of the container. And it's not specifically surface tension, but it's kind of like surface tension, that it's holding itself together because you've reduced the energy of the collection of atoms so much so that they want to stay together, despite this being a monatomic noble gas. It stays together when you make it that cold, and it just crawls up out. It's the second lightest, second most abundant element in the universe. This is kind of a weird thing, but if you were to look in stars, what you'd find is a lot of hydrogen and helium, because when the hydrogen fuses, it makes helium. So there's a lot of helium in stars, but as soon as it leaves the star, it gets very dispersed. So there's not a lot of helium atoms in open space. But if you think of how big open space is, that's a lot of helium. It is a non-renewable natural resource. Think about this for a moment. If you cannot break it down from a complex compound, let's say like water, you can split into hydrogen and oxygen. So as long as you've got water, you can get hydrogen, you can get oxygen. There is no compound that you can split and get helium. It's just helium atoms. So if you let them go into the air, they're gone. The atoms of helium are now on their way up, and you're not going to get them back. So it's a non-renewable resource. We can't kind of make it whenever we desire to make it from more complex compounds. So what do we use helium for? Well, everybody's favorite is balloons, launching balloons, whether it's party balloons, birthday balloons, or weather balloons, or high-altitude scientific research balloons. They all make use of helium and hydrogen. But it only goes up so far. Helium is very, very small, and it's monatomic, and it doesn't interact with things. So if you put helium inside your rubber weather balloon and you take it up to altitude, the rubber molecules will actually start to separate out, and the helium will begin to leak between the molecules of the rubber. And when you expand like that, you're going to have it, eventually pop the rubber balloon. The same thing even happens with mylar balloons, where it's holding in the helium a little better because it's better sealed, and the molecules of mylar hold tighter together, but eventually they stretch and it will rip the balloon apart. Another use of it is in pressurizing rocket propellant in tanks. So if you've got a Falcon 9 second stage and you launch it and it gets up to where it's, pretty much in orbit around the Earth, there's no gravity to make the fuel and oxidizer go to the rear of the tank where the combustion chamber is. So you have to oomph it, you have to push it, because otherwise it will just float as globules inside the tank. The way they do this is they have high pressure liquid helium in a small tank, and they vent it into the fuel tank and the oxidizer tank to push on it so it goes out the bottom. So whenever you have a rocket engine that's run off of liquid fuel and it's going above a certain altitude where it starts to have reduced gravity, or it goes interplanetary or deep space, it's not going to have gravity pushing the fuel to the bottom of the tank. It's going to be using helium. Now, the reason why they use helium is it's inert. It won't make the fuel go boom. So a little bit of helium goes a long way, because when it's a liquid, it's very small tank. But then as you vent out a small amount of it, it expands 780 times. So a very little amount of liquid helium expanded out into the fuel and oxidizer tank can keep the tank pressurized. But what it does say is when you run out of fuel or you run out of oxidizer, you've got a tank of helium that's not coming back to Earth anytime soon, but at least it's gaseous at relatively low pressure. It's not like a huge rocket fuel or oxidizer tank filled with liquid helium. The second thing we do is we use helium as something super cold to reduce the electronic heat, noise, and increase the sensitivity of all kinds of electronics. Superconducting electromagnetic maglev trains, they use liquid helium. MRI machines, in order to get a higher signal-to-noise ratio, they use liquid helium. You can often see on Facebook sites where somebody ditched an MRI, they didn't need it anymore, and somebody picked it up for a song, And the first thing they had to do was transport it. And as soon as they got it to its new destination, they just vent the liquid helium. You can see it venting it. And whenever you go to a place that has an MRI machine, these like mobile MRI machines, you'll see two vent stacks sticking out the top. And one is pressure relief for liquid nitrogen, which we'll get into, and the other is pressure release for liquid helium. So if you're into radio astronomy, as professional radio astronomers, you're going to use liquid helium to super chill your radio receiver so that it's not picking up outside electronic heat noise. It's really picking up signals from deep space. And in order to make imaging and spectroscopes work in deep infrared, they use liquid helium. The Hubble Space Telescope has a limited and getting lower supply of liquid helium. The Spitzer Space Telescope, after its first 5 years, exhausted its liquid helium because it leaks. We'll get into why it leaks. It leaked, and so you had 5 years of cold for Spitzer and 5 years of, they don't call it hot, they call it warm Spitzer. And the James Webb Space Telescope is going to do the same thing. It'll have about 5 years worth of liquefied helium used for chilling its instruments, and after that, the liquid helium will be vented to space by then, not all at once, but by then. And you'll have a warm period for the instruments. One of the questions I sent off to the subject matter expert was, okay, so the instruments need liquid helium, but the fuel tanks also need liquid helium aboard the same spacecraft. Are there two helium supplies, or is there only one? Because if there is only one, every time they reorient the James Webb Space Telescope, they may need to, fire up the thrusters and tilt it or move it or rotate it. And if they do that, that's going to consume helium. But if it consumes helium, how much is left for that 5 year period to keep the instruments cool? So one helium tank or two. And then the more modern one, which is quantum computers, use a large amount of liquid helium to cool their qubits, because if the qubits are exposed to too much heat or electronic heat noise, they destabilize. And one of the Achilles heel of quantum computers at this point is how long a qubit lasts without just being disrupted by outside influences. And so by using the liquid helium in the chamber that contains the computer, it can maybe last longer. So another thing that I found out was if you want to get rid of microscopic contaminants at these clean rooms where they make things like integrated circuits in high manufacturing volume, they use pressurized, but not liquid, pressurized helium to purge the chamber where the coatings of the integrated circuits are taking place, to make sure that the integrated circuits aren't inadvertently coated with other gases or dust particles. Some of you may be aware of something called Helioarc Welding. This is where you have oxyacetylene, but instead of using oxygen, you use helium, and the helium, being inert, does not corrode up the welded joint like oxygen, like oxyacetylene would. So we have Helioarc if you want to do very high temperature metal welding. Another one that I didn't realize is helium is used as a carrier gas in gas chromatography. So if you want to convey your sample into the chromatography chamber, you give it a shot of helium to push your gas to be analyzed into the chamber. And I did mention this previously when we were talking about metamaterials, that helium is used in electron microscopes to purge the chamber where the X-rays are going to be flying, to make the electron microscope work, because the helium tends to defend microscopic crystals like those of viruses from being attacked by the X-rays. And if any of you are into deep sea diving, you've no doubt heard of nitrogen narcosis and heliox. This is where helium is actually introduced into your air supply to help keep the nitrogen pushed out of your bloodstream, so that when you start to come back up, it doesn't form nitrogen bubbles and you get narcosis, because helium is inert. So you can, inject your oxygen mix with helium, and it will separate out the nitrogen, and less likely, not immune from, but less likely to get nitrogen narcosis.
Is that what makes them talk funny?
That's where it first came out that they talk funny, is the divers that are on heliox have the the Donald Duck squeaky voice, and it's just, that's how it works. And the other thing I found out was, if you have a light pressure of helium, it can be used as a thermal insulator, because apparently the heat doesn't travel well through helium because it's inert and a noble gas. And because it's so tiny, it's used in metamaterials at the nanoscale level. You strip off the electrons from the helium atom and you get a helium ion, which is very small. It's just 2 protons and 2 neutrons. But if you accelerate it using an electromagnetic field, you can actually use the core of the helium atom to blast away individual atoms of other material. Because it's inert, it's not going to react with it, so you're just literally pushing away atoms in some substrate that you want to carve something into. And fusion reactors sustain a lot of neutron damage. When you fuse the hydrogen atoms into helium, you have a spurious release of neutrons. And if your reactor chamber is filled with not liquid helium, but pressurized helium, it tends to reduce the decay, the neutron decay of the walls of your fusion reactor. So if fusion reactors become a big industrial thing, we'll need lots of, not helium, we'll need lots of helium-3. Helium-3 is an isotope of helium, where instead of having just 2 neutrons, we have 3 neutrons. And that apparently sucks up more neutrons and stabilizes and causes the neutrons to less affect the metal of the fusion reaction chamber. And then ultimately, yes, party balloons and making squeaky voices. For the applications where helium is meant to be extremely inert and not mix with anything, the helium must be extremely high in its purity. You can't have significant percentages of other stuff in your helium supply. So there are actually technical grades of helium. And if you have a tank of helium and it's minimally 99.99% helium, but if you have the remaining percentage as oxygen, that can cause corrosion. So, if you want to use your helium for MRI machines or launching high altitude research balloons, you want grade 6, which is 99.9999. So it's 4 nines past the decimal and 2 nines before. That's how you get to 6, 4 plus 2. Most industrial uses can tolerate a little bit of other things in with the helium, so they're at grade 4.7, so 99.997. The digit after the grade number is the last digit after the 9. So 99.997 is 49.7. But when you get down to the party balloon grade, where you don't care if there's mostly air or oxygen, as long as it lofts the balloons, you're good enough. That's grade 4. That's the basic 99.99. But there are some unscrupulous helium balloon supply vendors that might get your helium supply down to 80%. And if it's 80%, that's where you see the sad balloons. You go to some store or a supermarket where they want to sell you helium balloons, and you see mylar balloons that are up lofted in kind of the cage so they don't get out. And all the rubber balloons are like, they're already falling down. They're down low. That's because the oxygen interacts with the balloon material that's not mylar, and the helium leaks out because the oxygen in the impure helium is actually decaying the rubber of the balloon. So if you want to use the helium for industrial uses, you want as little impurities in it as possible. The remaining, 0.00001% of your industrial helium is likely to be argon or krypton, which are difficult to filter out through chemical compounding for the same reason that you're using helium. The argon and the krypton don't mix well with others. They're monatomic noble gases. So I went to a number of sites that will sell you helium, and they've come up with their own non-technical product branding. So you can have a place where you can, I'm going to go buy some ultra high purity helium. How high is the purity? They don't disclose that. It just makes you feel all warm and fuzzy that you're paying more money for ultra high purity. Or there's now I don't know how this gets by with the medical grade folks, but when you say something is US pure, USP, there are technical definitions for that stuff. So for the air gas folks selling USP, medical grade helium, I don't think that's the same stuff that they put in MRI machines. I think that's used for other things, maybe chromatographic grade. But way down below there is the balloon grade, which is what you can get at your local party store in the lovely pink tanks. So where does the helium come from? Here's why it's called helium after Helios. The first time they discovered this new element called helium was in 1868, and they discovered it first in spectral lines of the sun. They went through, they did their spectroscopic analysis of the sun. They got all the absorption lines. You remember those from our discussion of spectroscopics, the absorption lines, and they found an absorption line that they couldn't identify based upon understanding the chemistry of the things on Earth. But it came from the sun, so they called it helium after Helios. 1888 was the first detection in a spectral line of helium from a volcanic eruption on Earth. So they did the spectral analysis of the volcanic eruption, and there'd be helium in there. So in 1895, there's a material called clevite, which is a blend of uranite, which is raw uranium, and some rare earth elements. So they did the heating and spectroscopic analysis of that and found out when we do that, the spectroscope says there's helium in there. So that's when they started to make the connection between radioactive uranium and helium. It wasn't until 1903 that they found that natural gas being pulled up from beneath the earth, beneath the surface of the earth, if you do that above a source of uranium, you will actually get helium mixed in with the natural gas and oil. So the primary places on Earth for getting helium are from underground radioactive decay of uranium or thorium, which produces helium-4. The helium-4, after a while, decays down into regular helium, helium-2. So that's how they found that they can get helium is in gas, it's lighter, and it goes upward against gravity, and it's gone. They also found that in spectroscopic imaging of the thermosphere and the mesosphere, they found helium. So if you find helium in the upper atmosphere, that means it doesn't bleed all the way into space. It's kind of like if I fill a container full of water and I release something down low in the water that has air in it as a container, the container will bob up to the surface of the water, but it doesn't go any higher because the air is heavy enough that it fits in that layer. So if I were to fill that container with water and then oil, and I make it a light enough oil, the thing full of air would actually go above the water, but beneath the top of the oil because the oil is heavier. So makes one wonder if there's a layer of helium around the Earth in the upper atmosphere. So helium can be lost in nature by venting through cracks in those deposits. But since we don't go looking for it, we can't mine it that way. It needs to be captured at its underground source, because if you attempt to capture it at the surface, it's just going to bleed out around whatever your metal connections are and such. So you use the heavy layer of rock as a means of getting the conveyance materials, the oil and the natural gas, to bring up the helium with it, and then you extract it from that. So the amount of helium actually in a natural gas well is a small single-digit percentage. So if you're pulling out cubic tons per day of natural gas, there's a small percentage of that that's helium, and you can choose to separate it out. They found that there are volcanic gas release vents in East Africa. In 2016, they found out from spectroscopic analysis that that natural gas includes helium, which means if you have a under the surface lava pit, it's likely to have radioactive uranium keeping it hot, and that radioactive uranium will decay and produce helium-4, which will bubble up through the magma because it's inert, not the magma, the helium, and then it will collect into the natural gas, and then you can pull it out from there. So wherever there is underground lava as a source of natural gas, it's possibly also a helium mine. So how do you get the helium out of it? You can't just run like a very fine filter and separate out the helium, because helium being a very, very small atom and monatomic, you're never going to create a filter small enough to keep everything back but the helium. So what you have to do is low temperature gas liquefaction. So if you have gas coming up from one of these oil wells, and it's predominantly natural gas, which is nothing, predominantly natural gas, if you reduce the temperature of that until the natural gas becomes a liquid, then the more complex chemistries and the natural gas will be a liquid, but helium, hydrogen, argon, nitrogen, and some methane will still float above that. So that's your first level of separation, is you separate out the natural gas from all the other lighter gases. And you do that through low temperature gas liquefaction. Cool it first, separate out the heavier stuffs as a liquid, and now you've got the other stuff. So that extracted gas is only about 50% helium. So if you liquefy it even further, what you're going to bleed off is the methane and the nitrogen, because nitrogen goes to a liquid at a higher temperature than does hydrogen or helium. Helium requires the mid-level, and hydrogen requires the lowest level to go to a liquid. So if you want to get rid of the nitrogen and methane, chill it down further and split that off. And either the heavier gases will sink or become liquid, and now you're left with hydrogen and helium. So how do you separate out the hydrogen from the helium? Well, the helium's inert. So if you inject oxygen into the gaseous hydrogen, it will form water, and the water will sink and the helium will rise, and that's how you get to your 99.99 whatever percentage helium. I found that fascinating, that you go to the store and you buy yourself a helium-filled balloon for $1 at the dollar store, and there's helium in there that I think costs a lot more than $1 to fill your balloon. But because it's controlled, the price of helium is reasonable for party balloon use. But as soon as you want high volumes of ultra pure helium, that starts to get a lot more expensive. So there's only a few wells in the US, I think a total of 7, that they actually mine helium by way of mining it from natural gas. It then goes, apparently in this 50% state, to the US Bureau of Land Management, to private pipelines of the US government to do the remainder of the extraction of the helium, and then it goes into government-operated helium reserves, but not for much longer. This is kind of a turn of pace. During World War II, they found that helium was, sorry, not World War II, World War I. During World War I, they found out that this newly discovered helium is quite useful for military purposes. And so in 1925, the US government established the world's largest helium storage facility. They mixed helium with nitrogen. It's inert, but you can pressurize it. And they stored it underground in a depleted natural gas field near Amarillo, Texas. And this was operated by the US Bureau of Land Management and Mines. They added the and mines later. But that was as a result of the Helium Act of 1925. So the US government realized there's this rare stuff called helium that if you want pure supplies of it, you can use it in military industrial purposes. But you need to store it in a controlled manner, because if we ever lost our supply, our military would have a problem. So Helium Act of 1925. Apparently there are other newfound sources in Montana near, I think it's called, what do they call it, Four Corners? Near Four Corners. Apparently a lot of it escapes from Yellowstone National Park from the caldera. Remember me saying if there's uranium on the bottom and there's molten rock and it vents natural gas, that gas will contain helium? Yeah, Yellowstone spews out a lot of helium. But due to US regulations, you can't mine natural resources within a national park, so you're not going to be mining helium at Yellowstone. The Bureau of Land Management accepts this partially processed helium, stores it, puts it in these depleted natural gas mines, and then that's where your commercial sources of helium are. And the US has maintained that stockpile since the 1920s. However, because of all the new industrial uses, we've identified helium as a non-renewable critical resource. So we went from, we need it for our military and we need to process it and store it as a government natural resource, and it's super critical. And of course, what did we do? We ignored all of that. And the Helium Privatization Act of 1996, different administration, different money involved. Congress was a different animal in 96, if you remember. They said, ooh, there be money in our helium. How do we get private industry to start making that moolah? Well, Congress created the Helium Privatization Act of 1996, which directed the BLM to essentially close the operation and sell off the U.S. helium reserve by September of 2021, which is now. Absent any new additions or large-scale demands, the existing stored helium supply is expected to last all the way out to 2025, which is only 4 years from now. And we're finding all these new needs for helium. MRI machines, rocket launches, satellites needing it for fuel pressurization, electronics, and quantum computers, which is going to take liters per computer. But in the meantime, Congress has outsourced to private industry the mining, processing, and storing of helium. So it's going to cost billions of dollars for private industry to step up and start mining helium and storing it at the same scale that the US government used to do that. But since it involves risk, where you're going to get the helium from, it's kind of like speculative mining, and that costs money. And is private industry going to be willing to step up and do that? So why is it so difficult to contain helium? Helium be small. So Despite it being in underground reserves, some amount of our helium supply is identified as leaking out through the cracks in the rocks. A serious rock fracture, like happened at the methane wells out in California, all the helium would be gone very rapidly because it wants to go up. So if you want to store helium in a metal tank, you can do so because it won't corrode the tank, unlike liquid oxygen, which actually corrodes the tank because it oxidizes the metal. So given the tiny size of helium atoms, helium as a gas will leak through imprecise welds and around plastic gaskets. So you have to have metal gaskets under high pressure seal to keep the helium in there. Hydrogen's even smaller, but hydrogen easily mixes and makes into other compounds. So instead of the hydrogen all bleeding out, if you inject a small amount of oxygen, your hydrogen storage tank will transition and stabilize as water. You know, it'll go from pure hydrogen to some amount of water, which will tend to prevent the tank from leaking. So short term, you can store helium as a compressed gas in a metal tank, just like they do for party balloons. But eventually it will all leak away. And if you increase the pressure on it to try and make it longer storage, it'll actually leak away faster. And the more pure it is, the faster it'll leak away. So the first step to making the captured helium last longer is to liquefy it. So if you bring it down until the gaseous helium is liquid helium, it will last a little bit longer. But given that the expansion pressure is 780 times, even if you have a vacuum bottle tank to store your helium in, if the tank is outside and you get a sun going from behind the clouds to sun shining on the tank, given the expansion pressure, that is enough for the helium to want to vent, even though it's in a vacuum bottle. That small fraction temperature. So occasionally, you'll see that helium tanks will just vent, just cause, a change from cloudy to sunny to cloudy was enough of a pressure change that some of the helium is going to vent. And if you don't periodically top that off with new helium from where, I don't know, new helium, eventually all your helium will depressurize, go from liquid to a gas to depressurizing and leaking out. So it's hard to just store helium. So what's the next best way to store helium? Do two-stage cooling on it. This is how they keep the liquid helium liquid in an MRI machine. They actually add liquid nitrogen as not a vacuum bottle, but a tank on the outside of the helium tank. So you have the helium tank, metal, a liquid nitrogen tank, and then a vacuum bottle. So you're keeping the nitrogen cold to keep the helium cold and to keep the helium contained so it doesn't leak out through the tank. So this is why you see the two vents on an MRI machine. One is for liquid nitrogen, one is for liquid helium. If you look at a Falcon 9 rocket launch, you'll see a lot of things venting. There's the first stage, which will vent liquid oxygen because they use liquid kerosene and it doesn't vent. Second stage, same sort of thing. But at the top of the second stage, you see this separate vent all by itself going in a different direction. That's the liquid helium venting. So for long-term storage of very large industrial quantities of helium, they mix it with nitrogen and they put it under pressure under several hundred feet of supposedly solid rock, which is the solid rock of a depleted natural gas mine, which is what they typically use. Supposedly the nitrogen will mix with other molecules and seal the cracks down to a layer that, down to a size that the liquid helium will not easily escape. But even if you do that, who's to say that there aren't cracks in the rocks, or you might develop cracks in the rocks and then your entire supply is just gone. What it gets down to is we need new sources of helium. But first we conserve. So with the lead volume source of helium being sold off the private industry, and the Bureau of Land Management getting out of helium mining, processing, and transporting. We need new sources of helium. We need new processing of helium. And all of this is going to create new industrial infrastructure, which is going to increase prices for buyers. Get your helium party balloons now. Commercial uses of helium are growing. And whenever we find a new use, it's not a small use like, we'll need a liter per 5 years, like, electronic instruments. It's, hey, we're using helium for rocket fuel pressure from fuel pressurization. We'll need a couple of 100 liters per launch. So consumer grade helium being not even 99.99% pure helium, that means that your party balloons aren't really consuming vast amounts of helium, and they aren't sold all that often. So I would not look at party balloons as any sort of detriment to the helium supply. A more rational thought might be to come up with new approaches to cooling electronics and cooling superconductors, or maybe finally get to room temperature superconductors, because that consumes a lot of helium that is vented, that is spent, can't recover. So that's a lot of one-time use. And then rocket pressurization is another one. Maybe we could use argon for that one. Now, I know argon is not something that you'd want to use for it, because argon itself is not toxic, but argon is heavier than air. And wherever you have argon in a closed container, it displaces oxygen, which can cause people in that closed container to suffocate. There was an incident in Port Everglades, maybe 10 years ago, where the ship in its cargo hold had an argon container, and the argon was leaking. And somebody went down into the hole for other reasons, and he wound up dying. Passed out, dead on the hole. So what's the first natural response? I don't see any reason. There's no fire. So the next person goes down into the hole, then within a matter of minutes, they're lying dead on the hole floor as well, because you can't see it. It's a very, very faint yellow. But after the third person went in the hole and died, they said, let's call the hazardous materials folks. And they went, oh yeah, you got argon down there, and there's no air. So argon is not something you want to mess around with. It's still inert, but it displaces oxygen, and you don't want to be doing that. Maybe krypton. Well, krypton does the same thing. It's even heavier, and it displaces oxygen by it being heavy. So find another solution. Some of the industrial uses, like semiconductors and electron microscopes, are always going to likely require some pressurized helium, because if it's inert and submicron atom size. So there'll always be industrial uses for this non-renewable gas called helium. Maybe party balloons just need to be filled on demand. In other words, when you go in the store, they show you pictures on a board of the party balloons, rather than pre-filling them so you can just pay your $1 and walk out with your pre-filled balloon. Charge $2 for the balloon. Consume the store clerk's time to fill the balloon on demand. I think that will remove the whole, party balloon, birthday balloon, as being any concern for helium conservation. So additional mining on Earth. Like I said, wherever you find uranium or thorium, molten rock on top of it, you're likely to find helium. So we could speculatively mine for it in those areas. But as we become less reliant upon natural gas and we start having solar or splitting water to make hydrogen to run power plants, we don't need the natural gas so much anymore. And if you have electricity and the price of electricity is reasonable, you don't need natural gas for heating your home. So the demand for the natural gas goes down. How are you going to get your inadvertent supply of helium? So it may be that helium eventually becomes higher in price, such that when you go mine the natural gas well, you're not mining it for the natural gas, you're mining it for the helium content. But we should first look on Earth before we start looking off of the planet for helium sources, because there's still plenty down there. So mining the Earth's atmosphere for helium. This is controversial, but the mesosphere, which is from 30 miles to 53 miles in the upper atmosphere, it shows that there's a small percentage of helium per cubic volume. But given the size of the atmospheric shell at that layer, collectively, that's a lot of helium. They've also found that the Earth is spinning, and therefore the atmosphere actually bulges out at the equator, which may be higher concentrations. So if you just mined it at the equator, you may find that there's more helium. The actual amount of helium is not directly discernible. They've detected it through spectroscopic analysis, because how do you get up there? If the minimum height is 30 miles, this is well above where your balloons are going to pop. So you can't send up like a gas sucker on a balloon to go and pull in the helium and then come back down, because you're not going to get the balloon that high. The balloon's going to burst. You cannot fly a propeller or jet-driven aircraft 30 miles. That's 158,000 feet. There's not enough air pressure left to make the propeller meaningful or make the jet combustion work. And this is well above what the SR-71 can fly at. There's just no air. You have to bring your own, which is where rockets come in. Rockets bring their own oxidizer. This is why you'll see something like methane or kerosene and then oxygen, and you mix the two, and that's what makes your rocket fly. So you bring your own oxidizer because there's no air up there. So how do you get something up that high for a long duration period of time to do your mining without using propellers, jet engines, lighter than air filled balloons, or rockets? The reason why you can't use rockets is rockets have a short specific impulse. This means when you ignite it, it starts going fast, but that ignited propulsion does not last long. It lasts, seconds. So if it only lasts seconds, you need to be going really fast before your fuel runs out. So by the time these atmospheric research rockets are into the mesosphere, they're doing at about the point where they curve and they start coming back down, they're doing almost 90 miles per hour, and then they're coming back down. So we need to develop new forms of mining equipment that will get you up that high long enough that you can mine it. But, that may be expensive and speculative, but that's going to be far cheaper than mining it off planet. So off Earth helium mining. Yes, there's helium out in the universe, all kinds of it. So on the moon, during the 2 presidential administrations ago, there was a lot of interest in helium-3 mining on the moon for fusion neutron decay mitigation. But apparently that all dropped off when word got out that, we really want to go back to the moon for helium mining for our multi-billion-dollar friends in the industry that can use it in fusion reactors. So when they got found out, it kind of lost its influence. But wherever you find subsurface gas pockets of uranium or thorium, be it on planets, on moons, Io comes to mind, you're going to find helium. But you want to do it so that it's cost effective to go up there and do it and bring it back. And the one that came to mind was the planet Jupiter. Its outer atmosphere is 10% helium. But there's a lot of it, because 10% of something that's that big, the biggest planet in the solar system, is still a lot of helium. But you have to go there, suck in the upper atmospheric gas, spit out the stuff you don't want, and then haul the helium back. Well, it might actually be cheaper to haul it back and store it on the moon than to bring it all the way back to the Earth. Because if you remember, they found out that there's these lava tubes on the moon. This is where lava originally, millions of years ago, flowed subsurface on the moon, and that lava has since cooled down and solidified as rock. So you have these lovely tubes that if you close off the ends of the tubes, you can pump your helium, mix it with other gases in there, and it will be just like one of the natural helium containment chambers here on Earth. But it's on the moon, so it costs less to get it there. And if we're going to go back to the moon, and we're going to make it cheaper to go to the moon and come back, there you go. But it's likely to cost billions of dollars, and until helium gets to be a lot more expensive on Earth, nobody's going to want to spend the billions to do this. So when we start running out of helium on Earth, when we can't find it easily here, and we've found ways to mine it in the atmosphere of the Earth, once we exhaust that, now you're talking, go do the big industrial mining off Earth. You've probably seen some science fiction movies of this, of atmospheric gas mining off of like Jupiter and Neptune and Saturn. So in conclusion, although helium is abundant across the universe, it's scarce above ground on Earth because it floats away. It's costly to process and difficult to store. And every time we think about new industrial things, we come up with, oh, I'm going to need some more helium for that. And it's not just small quantities, it's large quantities. So the typical uses of helium in large quantity, it disposes of the helium as either the act of doing what they're doing or when they're done with it. So if you have your Falcon 9 upper stage that uses helium to pressurize the oxygen in the second stage, when the second stage falls back to Earth after, maybe a number of weeks or months, and it burns up, that helium goes into the atmosphere. It didn't mix with anything. Even if the second stage burns up, the helium is just going to go up. So get it from the mesosphere. So first mine all the sources beneath the surface of the Earth. And then go up and mine it in the mesosphere. And only then should you start considering doing industrial scale mining off Earth. But in the meantime, keep your rational perspective and don't focus so much on party balloons. They're an ant on an elephant. Any other things that I didn't cover about helium?
Very interesting. Thanks, Monroe.
So were there any remaining questions you had about helium that I probably went way too deep into it?
No. It was good, and you answered all my questions.
Yeah, very uplifting.
Well, I like the title. What's up with helium?
Yes, clever.
That was clever. So you say that we're running out of helium.
Yes.
But are we running out of helium, or is it because people aren't mining for oil as much?
No, we're running out of helium because of an act of, remember, we didn't have the National Helium Reserve until the U.S. Congress decided, hey, this helium stuff's hard to come by, and we need it for all of our military industrial stuff, so let's have a National Helium Reserve. And then 2 administrations ago, when somebody said, hey, the government's, the sole source of helium, because the U.S. government maintains the reservoir, therefore private industry can't come in and get a sweet slice of that pie. And so Congress said, the U.S. shall no longer do that. And it'll be up to private industry to provide us with our helium. Apparently, how private industry is not willing to spend the billions to step up. But we're now at September of 2021, which by act of Congress was when the U.S. government, the Bureau of Land Management, is supposed to stop maintaining and operating the U.S. National Helium Reserve. So it'll be interesting to see what Congress does.
How much is in there, though, too? Like you're saying that
about 4 years worth. About 4 years worth at our at our regular level of consumption. But meantime, we're launching more rockets. We're building more MRI machines. And we came up with this new multi-liter per instance use of it in quantum computers. So I think they need to go back and recalculate what they think of as what's left. Because what's left being 4 years before we start adding all these new consumptions in, maybe 1 or 2 years.
So now
this uranium isn't limited. I mean, we're not running out of uranium or this other thing.
No. If you think about it, the reason why there's so much molten rock beneath the surface of the Earth is uranium deposits keep it hot. So I think the decaying uranium will always be there for as long as there's an Earth. I think the ability to pull helium out of natural gas sources is going to be there. But it's the profitability of it. If we no longer find that natural gas is profitable to speculatively mine it, then that reduces our helium sources. So until helium as a gas starts to be priced at the same level or higher than natural gas, I don't see the industrial viewpoint of this changing.
Well, won't it change because of the viewpoints? I mean,
well, that's what I'm saying. That's what I'm saying.
Why did they make it so low of a cost anyway?
Because the government artificially kept the price low back when they were maintaining the reserve, so that industrial uses of it would be not burdened by high price.
Yeah, you know how low the price of helium was? My kids, while they were growing up, got a free helium balloon every time they went to Publix.
Yes, Publix used to give away free helium-filled balloons. These are the little round ones, and they were rubber. But nowadays, the cheapest helium-filled balloons that I've seen are $1 a piece at the dollar store. And
yeah, it's getting more expensive to raise kids.
But whenever I go to the dollar store, I always feel sorry for all the helium atoms that are trapped in all the Mylar balloons that are just sitting there waiting for somebody to come by and go, I want one.
Yeah.
The Goodyear and Fuji and other blimp flyers may have to cut back as well.
Yes.
But if we're not going down there to get, we're having less. Are we getting less oil now? Is it already a problem that we're decreasing in the amount of oil we're using, right?
Yes and yes. The amount of oil we can get is in decline. It's not dramatically declining, but it is detectably declining because certain reserves are kind of running out, which is why we're fracking rock. We're fracking shale to get oil that would otherwise be easy to pull out of the ground. We're now having to frack the rock and then use high pressure water and detergents to push the oil out. Because
so those don't give us the helium if we frack the rock?
No, it's going to, because it's oil and the oil has natural gas in it. So but the question is, if you ever look at a fracking mining site, you'll notice that there's a gas flame pipe in the area that's burning off the methane because it's not in high enough concentration and the processing facility isn't close enough to make it meaningful to mine the natural gas from the oil well. They're there for the oil, not the natural gas. So they just burn it off. When they burn it off, there goes the helium too.
Okay. So,
but if you're at like Honey Hill in Pompano, Garbage Mound, Florida, that natural gas does not have helium in it because there's no uranium decaying beneath the mound. The helium actually comes from the decay of uranium.
So the solution would be to get more nuclear waste spread in our garbage facilities.
Yes,
you need.
Yes.
Yeah, when you take the uranium and you use it in industrial fission reactors, the uranium that comes out of it is not the same kind of uranium that's underground. It's a more stable form of uranium, so it's less likely to produce helium-4 for you to mine it. So even if you said, why don't we take all the spent uranium from all the power plants, and in that underground storage facility they've got out at Yucca, let's just mine helium there. It's not the sufficiently energetic helium, uranium, and besides that, it's buried in metal and concrete containers, and we don't want to vent those because you can get plutonium out of that, and that would not be the stuff that would give you your helium.
Yeah, and it also takes a long time to get that much helium. That I think somebody was asking before, isn't there a lot of uranium still under the earth? There's still a lot of the uranium, but the problem is that when you get the helium out of natural gas, out of a natural gas well, that's not helium that's being produced on the spot. That's helium that's taken millions and millions and millions of years to produce. So really, it's not practical to get it out of uranium.
Well, if you have a natural gas source that's already there and it's sitting on top of a uranium source, that is a current mineable source for helium, but it is of limited supply and it's non-renewable. However, I think that Earth mesospheric mining of helium is an abundant source. I don't think helium actually bleeds off the planet. I think hydrogen might, but I think the helium is actually trapped in the upper layers of the atmosphere below the point where solar radiation can interact with it. And therefore, if we could just find a way to send up the appropriate craft to do a long-term study of that layer of the atmosphere, I think we'd find it to be an abundant source of helium. Because if it doesn't bleed off into space, then every helium atom ever released from the Earth should be in the upper atmosphere. And that would make it renewable, because as soon as we vent it on the Earth out of an MRI machine, it just goes up and we bring it back down again. But if you send it up in a rocket,
it before it went up, like put something over the building or wherever it's at so it doesn't escape, a tube, not so it goes in the air right around us. But
the releases are ad hoc. If you happen to be a hospital with a MRI machine, I think there are requirements for you to vent and capture the helium.
Oh, okay. That's good.
But if you're some knuckleheads that have bought a defective MRI machine and just want to have fun venting the helium, it's going to be gone. Nobody's going to catch you and stop you from doing it.
People could buy MRI machines just to mess around with them?
Oh, yeah. There's a lot of copper.
Around with an MRI machine. I mean,
there's a lot of copper in the magnets. If a hospital is saying, I want to upgrade our 1.5 Tesla MRI machine to a 3 or a 5 Tesla MRI machine, there's not a lot of demand for a 1.5 Tesla MRI machine. They're just not good enough. So there's not a lot of resale value for them. So they get sold for their materials cost, for the copper in the magnets. And those guys don't care about any silly helium. They're there for the copper. But they have to vent the helium to get at the copper.
And they don't have to collect it.
Nope. They're under no obligation. They're junk dealers.
They can't get any money for the helium?
They would have to contain it, and it's pressurized. So they would have to spend money to sell it. And right now, if you can get your party balloon for $1, there's not a lot of money in helium. So until the price of helium goes up dramatically, there's not a lot of incentive to consider helium to be a non-renewable resource. Oh. It's the big picture, the data, the finances, the shuffling of money from one hand to another. Yeah.
And obviously, I mean, you did a lot of research on this. It's obvious and it's great. But did you do the research as to if there's any proposals in Congress to look at this?
I did not see any proposals in Congress. I think they've got friends that are out there just waiting for the okay, we got to shut it all down. And then somebody big that is a friend of a friend will step in and go, we'll take that on. And now the price of all your party balloons went from $1 to $5. So until the price of helium goes up dramatically, nobody's going to step in. Because it was artificially lowered for so many decades.
So you think all along we should be charging $5 for balloons?
Yeah, probably.
Well, it's weird how things work sometimes.
It's called business. It's called business, and it's called business that pays money to government to get all the right acts passed through Congress. And yeah. If I had my druthers, I'd say, let's rescind that last congressional act we did and go back to having the U.S. government not only maintain the helium reserve, but the U.S. government becomes a mining agency for getting more helium, because we're just going to find more and more uses for it. And that's tax dollars I'm certainly willing to spend.
Because you believe that the government will make money off of it too.
No. I believe that the government will still have to have a depressed commercial price for helium.
Oh.
Otherwise, it becomes what they originally thought it would be, a barrier to new technology using helium for industrial purposes. That's, but between uses in the military and the desire for industry to have cheap helium so they can do industrial scale things with it. That's the whole reason the reserve was created and the price reduced or depressed in the first place. And now, it's all bets are off. It's free for all. Let's open up the free market and helium will float up to whatever price is appropriate.
Is there a possibility the government will take it back on?
I see no indication of that at this time.
No.
Well, listen, look what the government's done with rare earths. Who has all the rare earth metals that we need now?
China.
China, because it was cheaper, because it was good for business. I'm surprised that China doesn't hold all our helium reserves as well.
That's because I guess we have more natural gas wells in the U.S. than they have in China.
Yeah, of course. Why not ship our helium to China to have them hold it for us?
Well, where do you think China gets the helium for their rockets?
From us?
Us.
Do we do that for other countries too?
Well, yeah. Otherwise, space exploration grinds to a halt on Earth.
Because helium is found in the United States?
Yeah. The largest number of helium wells is in the United States. I think there's 12 total on Earth, and 7 of them are in the United States.
And so the other wells are drying up too?
Yes.
Because they're being utilized.
Yeah, it's like anything that you're going to get as a non-renewable resource. It took millions of years to create it, and you're going to suck it out of the ground in a few hundred years.
Yeah.
Because remember, what was it, 1908, that we first started coming up with industrial uses for helium?
So, giving us a quiz?
No, I had it in the slides.
I know, that's a quiz though. And you said, what is it? That's good.
Yeah, you should put a test at the end of each presentation. See what we learned.
I will never do that to you.
Thank you.
We'll all take notes.
What was the other element besides uranium? It was another thing that I hadn't heard of before.
Thorium. Thorium. You may hear of thorium as in thorium liquid salts fission reactors. That's a big thing.
Or China's new thorium salt reactors.
China?
Yes. Okay, let me reshare this. Sources of helium. So in 1868, we found it on the sun. In 1888, we found it in a volcano on Earth. In 1895, we actually found you could separate it out from uraninite. And then 1903 was when we first started extracting it from natural gas wells. So it wasn't until the early 1900s that we actually started using helium for industrial purposes. Think of it this way. If it was 1902 and you had a birthday, it was impossible for you to get a helium-filled balloon for your birthday.
I don't think they made Mylar then.
There was no helium.
I know, but to get a Mylar balloon, you got to fill it up.
No. You filled your balloon with hydrogen.
Yeah.
So until 1903, if anybody got a lighter than air balloon, it had to be filled with hydrogen, not helium. But, you know, helium balloons don't go boom. So, well, any other comments or questions about helium?
It says here that the last one about the volcano gas and
Yes.
it's releases helium. Can we capture that?
No, but what it means is wherever there is magma, molten rock, you probably have a source of uranium beneath it. And if the uranium is decaying and producing helium-4, which will decompose into helium-2, the normal state of helium, then you should be able to, wherever there's a underground magma source and there's natural gas coming up, find helium. It's just like, you know, A begets B begets C, and there's your helium. So it should not be that speculative to go mine helium. You just find wherever you had a natural gas well, and there's probably still helium down there. So even after the gas well starts to run low on its pressurization of natural gas, there's probably still helium there. So I don't know if you've noticed it in the news. It didn't show up as space or astronomy news. The state of California would like to cease all of those rocker arm oil and natural gas wells in the state of California. If you go around Southern California, there are places that there's just one of those suckers every 20 feet. And they're just rocking all the time. And what they're pulling up now is loose mixtures of poor grades of oil with natural gas, and they have to separate out the natural gas.
So why do they want to gather them up?
They want to shut them all down because they're polluting. They're bringing up natural gas, methane, which is a stronger greenhouse gas than is CO2. And the oil that leaks around them creates a surface pollution. So by saying we've got other sources of natural gas in the United States, we don't need the oil wells because we've got fracking that does that. We don't need the natural gas mining because we've got other places that do that. So all of this low-grade rocker arm stuff that we're doing in the state of California, let's just stop that. So we'll see how California's government deals with that. But now
Would
that
be a good thing? It sounds like that would be a good thing if they're causing pollution.
yes, it would be a good thing, but that's just my humble opinion. But now that Gavin Newsom has been assured he can stay in office until the end of his term, maybe the California Congress will say, yep, now that Gavin's still there, he's going to sign it off. Let's, you know, because once you remove all of those rocker arm well pumps and you clean up the oil pollution from the surface, that's a lot of real estate that's up for development. And what's going to make you more money in the state of California than depleted oil and natural gas wells? The land, because they don't make any more of it.
But the land is owned by the oil companies, right?
I think you're going to find that It's owned by other than the oil companies, and they just pay for the mineral rights. So if the oil company says, oh, damn, the state of California is forcing us to not operate that anymore, we're no longer going to pay you for mineral rights that we can't get. So the land reverts back to the original owner.
Which is
whoever's going to be responsible for cleaning up the oil left behind, all the surface, pollution.
You're saying when they pass this law that they're going to pass a law that says you have to clean it up also? No.
I don't think they'll pass a law that says you have to clean it up. I think they'll pass a law that says you have to stop the mining, stop the wells.
Right.
Yeah.
And you think they'll clean it up so they can sell it?
I think it will be up to the land owners, not the mineral rights owners, up to the land owners to clean it up. And the poor landowners, if they can't clean it up with whatever funds they have, I'm sure that big business will step in and say, we'll buy up this many thousands of acres and we'll clean it up because we want to build condominiums, public storage, and shopping malls on it. And that they will make billions.
No, Monroe, I'm quite sure that's what they want to do. But what they'll say is, because we love the environment and we want to clean it up and we want to make a safe world for everyone, so we'll take it over.
You might also find that the people behind the California Congress wanting to cease the oil mining are also the ones that realize they're going to have friends that are going to make land money.
So they're really not out for the environment? Are you telling me that?
No.
Yes, I am. Yes, I am, but that's my humble opinion.
Yeah, maybe they should drill for water.
Drill for water?
There's no water out there.
This guy and his water and his pipelines and the West and the fires.
Remember, California is a desert. There is no water out there. You have to pump it all in.
Pipe it in.
Yeah. But they did a good job of it for a long time, making it look very lush.
Well, that was back when an adjoining state had this huge water reservoir that they could just, draw from. But now that reservoir is very low because of global climate change and the heating, and the reservoir is getting to be less and less, they're not so willing to share with their brothers in California anymore.
Or Mexico.
I think Mexico can get it from further down in Mexico. I don't think that they're that reliant upon the U.S.
They were. I'm glad to hear they got it from somewhere else.
I think they found other sources for it. The Rio Grande River still is, a trickle of its former self because of the dam. So they have to find other sources. I think ultimately, if we really want water, we need to start splitting it out from seawater. So you create the electricity, and the electricity becomes your universal panacea for solving whatever problem you've got. So if you want to run your power plant, you store the water, you store the electricity, you split the water, you create hydrogen, you run your power plant. Closed loop. Because when you burn the hydrogen and oxygen together, it produces water, goes back into the system again. If you're in an area like California where it's a desert, I've been in California a number of times when you would drive over these very long, low bridges, and there's no water in this very wide canal. It hasn't been for decades. There are full-size trees growing in the dirt that was once a river. So California is a desert. If you want to make California lush again, find a way to industrially split the water from seawater.
And you think they're working on that?
Well, I know that it's available other places on the earth. There are places in the Middle East where If you want any water at all, you have to split it out of seawater. But they use osmotic filtering, and you have to back flush those filters periodically because they get clogged up with salt.
Yeah. But they work, right?
Oh, yeah.
They're
That's their water supply. That's their water supply. But the water pressure isn't that high because they don't do it on a huge scale. They do it on as needed for the local community. And if the local community grows, they don't go out and build a second desalinization plant. They just say, okay, we're going to cut back on the water pressure because too many people are drinking from it, using it. And heaven forbid they, start an almond grove. Almonds consume a lot of water.
Almonds are grown not in California, though, are they?
Oh, absolutely. The largest almond horticulture occurs in the state of California.
I know they were having problems out there with growing rice. And
the rice is different. The almonds.
But they needed water.
Yeah, the almonds suck up the water into the tree, and the tree grows and produces almonds which contain water. So when you shake all the almonds loose from the tree, you're taking the water away. If you're growing rice, the rice plant itself is fairly small. So when you pull up the rice plant, it's still sitting in a pool of water. The biggest consumption of water in that regard is the evaporation of the water. It's not the rice plant itself that's sucking up so much water. It's a very large, flat, shallow area, and you have to keep it replenished with water. Otherwise, it just evaporates into the air.
Right. Well, they were having trouble with that a couple of years. Well, I don't know. It must have been 20 years ago now.
Yes, but I think several presentations ago, I put up a graph that said, compare the amount of water consumed by rice versus other food crops, and almonds and some other, was it beets? Almonds and some other food item were just massively more consuming of water because it takes it up into the plant. The plant itself is not renewable. You have to keep the plant for decades, so it sucks up the water and it's all captured and doesn't come back. And when the food product goes away, it takes water with it in the food product. So, rice is recycled. The water in the rice is recycled because it goes up in the clouds and then comes back down as rain. But when it goes up into an almond tree and out into almonds, it may show up again when you ingest the almonds and they come out the other end.
But if we wanted to, as a society, couldn't we make the deserts bloom?
Oh, absolutely. We just need to spend the money on desalinization.
We just don't get together to do that.
Well, if we spent $1 billion to come up with an evaporative industrial scale plant, and we put those in California, who's going to pay for that?
I've got $34.
That's the thing. And that's the thing is, sometimes what a society needs is something that collectively a society must, as a sum, give into that. So if we're running short of water, there is no industry that's going to create it on its own because there's no profit in it. You have to have a government, a social collective that spends its collective value in producing that resource. That's the only way you're going to do it. I mean, there have been funny movies about scarcity of water and it being controlled by private industry, as if the private industry was a military. Has anybody seen the movie Tank Girl, Lori Petty? Years ago, it was a comedy. Malcolm McDowell played the evil head of the corporation that behaved like a military leader, and he controlled water. And the average person got just enough water to survive and no more. Because if you have too much water, you become wealthy. And wealthy has unlimited supply of water. And they eventually got to the point where water was so scarce, when they killed people, they sucked the water from them. So they created this device that if you wanted to get rid of someone, you literally jabbed it into them and it would suck all the water out of them. It'd leave all the other materials in there, and the only thing that you get is a container full of pure water. So it was an osmotic filter.
They do that in Dune also, right?
In Dune, water is considered a scarce natural resource, so they create these things called still suits, which is basically if you get any water into your body and then it comes out of your body through whatever means, including perspiration, it collects the water and purifies it, and then all of the people of that society collectively share their water in underground catchments. And that's how you dealt with the government wanting to control water.
Right, but when someone dies, they literally put you in stills to get your water.
Yes, they don't bury you because that would be a waste of the water, and they don't cremate you because that would be a waste of the water. They put you in a machine that extracts all the water from you and then takes the rest of it and fertilizes the land with it again.
Yeah,
we're not there yet. We're not there yet. So let's first go with if we have a natural resource that's in limited supply, use the collective power of a social or governmental organization to create that much desired resource at a suppressed cost to keep things rolling. Don't take it the other direction and say, hey, look, that's scarce. That's how I make my billions.
The movie Chinatown was about that.
Yes, that was about water in California.
Yeah.
So what are we talking about next week? Let's see. Let me pull up my thing there. And, next week is air purification, ozone, and ultraviolet.
Oh.
So this is another fan suggested, member suggested. I think this was Joanne that suggested this one.
Okay.
So we'll deep dive on that next week. Well, I can tell you what I'm always working on 3 or 4 projects at the same time. And I finally gathered enough mental concentration together to start working on my radio astronomy antenna again.
Oh.
And this is a damped sinusoidal curve. It's a sine wave, but it gets smaller. This is the actual shape of the antenna radios that I'm going to be producing. But they're not, they're too flimsy like this, obviously. But if I take them and I put 4 of them around a cylinder, and then I mathematically curve them to form the outside of the cylinder, and I change these from being rods to actually being depressed curves into the cylinder, then I can run wire where you see these zigzags. And if I wrap them around a cylinder and I put wire in them and I make it larger, I can now have myself a very wide band radio antenna that takes up very little space and is lightweight, so I can mount it on telescopes.
Oh, nice.
So, springy.
Yeah.
But I pushed that to the limits of my 3D printer. It printed, but I only filled it at 10% because I didn't want it to take 5 hours to print. I've got one queued up right now that once we're done with this session, it's going to take 8 hours to print, because it's a cube. It's a tall cylindrical cube, and then it has 4 of those zigzags, and they're impressed as a subtraction. They're subtracted from the outsides of the cube faces, and the cube is hollow down the center. So, but next week, if it works, I'll get to show it off.
One of the things we talked about last week was the possibility of tsunami someday.
Yes.
And over there in La Palma Islands, Canary Islands, that one volcano we were talking about has a whole series of little earthquakes right now. They're under a yellow alert in Spain. So maybe that's good, and that it might take some relief off of a major explosion. But it's interesting that the yellow alert is a pretty rare thing over there.
Well, the other thing that happened was, I think today there was a magnitude 4 earthquake out in California. So wherever you have stress on tectonic plates, you're going to have periodic earthquakes, and it's actually good for the plates to get that out of their system at the 4 or 5 level to keep things moving, keep things moving. If all of a sudden you hear that they're not having the minor quakes that they used to have, that's when the big one gets queued up.
Right.
So it's okay to hear that they've had recurring 4s and 5s. It's numbers higher than 5 you don't want to hear.
Geologists talk about Canaries. It's in a pretty precarious place when it comes to tectonic plate.
Yes.
So it's not a good place to be.
So here's something that I watched an episode of Physics Girl on YouTube. She's fun to watch, Diana Kerwin. If you go on Google Earth and you look at the Hawaiian Islands, you'll see that the Hawaiian Islands are where they are now, but they haven't always been there. The vent that is like the Kilauea volcano actually moves across the surface of the Earth as the tectonic plates move. So you can actually see undersea mountains that trail off towards Russia, where the island chain of Hawaii was, for tens of thousands to millions of years ago. And it's only recently that the volcano is spewing enough magma to create the current Hawaiian Islands.
The hot spot is below the plate, and as the plate moves, the hot spot periodically bubbles up and creates another volcano or another island.
Yes.
So we should be buying property south of the hotspot.
Well, that's where the property is being created. That's where you see the magma rolling off into the ocean, creating hundreds of acres of new land every year.
Yeah, I know. I was thinking further south. We can predict it, and then 4 or 8 million years, it'll be really.
Yeah, I don't think you're allowed to, by international agreement, buy undersea. So I'm going to go over to Hawaii. Hawaii, as I forgot.
Godfrey, yeah.
So while you're doing that, so Inspiration was actually higher than the Hubble Space Telescope.
It was higher than the ISS and higher than Hubble.
Yeah, so that begs the question, why couldn't SpaceX be engaged to possibly do repairs and maintenance on Hubble? Keep it going longer.
Congressional incentive.
Ah.
I know. There is no technological reason why once Starship is operational by SpaceX that they cannot service the Hubble and they cannot do whatever repairs are necessary to the International Space Station. They will be able to haul large enough cargo to do that.
Oh, there we go.
There you go. Isn't that cool? You can see where the Hawaiian Islands used to be.
Yeah.
Now, if you look at these undersea mountain chains, they're actually what is known as a geo. Anybody out there know what a geo is? Okay, a geo is if you have an undersea volcanic eruption and it produces a mountaintop, then over millions of years of the ocean waves whopping up against the shoreline, it eventually shreds the top of the mountain off if it's not too high. And the other thing is sea levels are rising. So what used to be the Hawaiian Islands chain actually is getting flat top, so it's below the surface of the ocean. Do you see that? So all of this was formed by lava from an extinct volcano that is now beneath the Pacific Ocean. I can spend hours in Google Earth. Now this big blue blob is actually a satellite camera, a satellite image. Because if I go like this, say it zooms in, and you can actually see there's actually an island there. So the peak of what used to be this giant mountainous volcanic chain is still there. But it's a little tiny island now. Can I get closer? Yeah, there you go. Oh, that's funny. Apparently this outcropping of rock is small enough that when they took the picture of it, they took it via helicopter. That's how you get this circular wave action. You notice once you get beyond that, the circular wave action goes to a satellite image. Oh, that's interesting. The former Hawaiian Islands actually includes Midway Island.
Midway. What's that box to the upper left from Midway? Oh, never mind.
I can go back in. The box to the upper left of Midway.
Yeah, go back to Midway.
Midway. Where Midway is, that's square?
No, it wasn't on Midway. But it was a square like that.
Oh, okay, up here.
Yes.
That's just another island, and it's it's not a satellite photo. It's just an aerial photo of it.
Oh, so that box is, I guess, something that got more detail.
Yes, it's just as you zoom up, it's a different layer.
Yeah.
I zoomed up on it. Give it a moment, you'll see it. But as you get closer to Russia, the names of the islands start to get a little more Slavic. So ain't that fascinating?
So I wonder where the native Hawaiians came from.
Well, it depends upon how far you go back. I look at it this way. We're all Terrans, and we all at some point came from Africa.
You remember they used to, I think most of us are old enough to remember, they used to actually get sailboats and make them, or canoes or sailboats and make them out of big logs and see if you could sail from, what was it, South America to Asia or Asia to South. Thor Heyerdahl and those people did it. And now, of course, it's genetics, right? But they used to do all these wild voyages and speculate where they came from.
Yes, it was Kon-Tiki and Kon-Tiki 2.
Yep.
History.
You even remember the names? Oh, my God.
Well, I was going to let you come up with the Thor Heyerdahl. But since you didn't come up with the Kon-Tiki, I thought I'd throw that in.
It was Jesus, this is stuff I read in like 5th grade or something.
Yeah.
And you remember it?
Okay, the reason why I have that as a more recent memory is there is a public high school in the city of Weston that their students formed an amateur astronomy club, and they signed up to do the NASA multi-generational spacecraft thesis. And they called their multi-generational spacecraft Kon-Tiki 3.
Yeah.
Because the idea would be build a spacecraft that has all the problems solved, that once you leave Earth, you're never coming back again, and you have to have everything you need for generations absent faster than light travel to get to the next nearest star. So, what do you call your ship? Well, Kon-Tiki 3, of course. So you can literally see the edges of the Pacific plate. Yeah. See how it goes from the left side, goes around underneath Alaska and down the west coast of the U.S. That's the Pacific plate.
Mm-hmm. Pretty amazing to see it like this.
So there's an application called Google Earth, and you can get the professional version, the pro version, and it used to cost you $1,000. And at some point, Google said, we've already let the cat out of the bag too much. We're not making any money off of it anymore. the news media doesn't want to use it anymore. So we'll just give everyone who wants it free license to use Google Earth Pro. I have Google Earth Pro, and I got it. It's a current version, July of 2021. But for anybody who's really wanting to look into all this stuff, I highly recommend Google Earth Pro. I've used it for years for a number of things.
You know how often a given section of this is updated?
Constantly. The data is cyclic and 3 years old is the best way to describe it. Google doesn't pay any money for this stuff because there's no money to be made off of it. So whenever a government releases their data into the public domain, Google Earth is there to snap it up and update things. They just update stuff. So, for example, if you look down here, you can see where it says places outdated, roads outdated. They just recently realized that their information was out of date, and they're in the process of updating.
This Google Earth, by the way, has enough resolution that if you zoom over my house in Miami Beach, you can see that the roof needs patching.
I'll show you how old some things are here. If I go look for, so here's where my house is in Palmer Village. And I looked up the information to find out where the nearest SpaceX Starlink ground station was. And it's right over here.
Huh.
So how I found that was, well, if you're going to have a ground station that transmits up to a satellite, that's got to be FCC approved. So you go look on the FCC's public information, and you find, where this Starlink satellite antenna is going to be. And it's listed as, they're going to put it in this parking lot. There's a huge data center here in this building, and this is an AT&T switching center. So you have satellite, data center, communications, internet backhaul, all in one spot. But that's how detailed SpaceX is getting on this stuff. And as the crow flies, it's only 5 minutes from my house. So when they finally go out of beta and they start doing production on Starlink, and they finally fulfill my request and send me a dish, it will be from my house up to the satellite going overhead, and then right back down to this data center. So the transit time for me to get to an internet backbone hub is going to be reduced by 100 plus milliseconds, because right now I'm on AT&T wireless, which is backhauled to Gainesville, Florida. So when my home connection goes to AT&T, it doesn't go to the internet right away. It goes all the way up to Gainesville, where there's a fiber optic trunk that joins the internet backbone that goes up to Atlanta, Georgia. So that's where it ties in. But if it comes to here, it ties into the internet here.
But
because
surely,
this is a backbone site.
Surely terrestrially to Gainesville is less than to a satellite.
Think about distance. If I have to go from my house to Gainesville and then switch to get up to Georgia to get to a data center who has a mirrored site 5 minutes from my house, that's a lot of ground traversal that I have to go through in order to communicate with that server. However, if it goes from my house to 300 miles up and then right down to this ground station to the data center, that's a much shorter hop because there's no switching. There's the satellite and then it's back to the ground.
Well, that's 600 miles. But you're right, it's without
How far do you think it is to Atlanta, Georgia?
Switching.
Remember, even if it gets it to the internet backbone in Atlanta, Georgia, if the data center mirror is right here in South Florida, it's got to go from my house to Gainesville to Atlanta and then back down to South Florida to get to that data center. So it's like up to Atlanta, back down from Atlanta, and then over to this data center. Not that I'm doing stock transactions that require millisecond accuracy.
Is that FLL Airport right there?
No.
No, this is Executive Airport. 5 minutes from my house.
Uh-huh.
remember when we were talking about weather? There's a weather station right near the tower that is my nearest official NOAA weather monitoring station. So I go to the internet to get data from a weather station that's 5 minutes from my house.
Yeah.
But that was how local weather is. Okay.
So you don't think you think that you're going to go up to the satellite, back down again, and that Starlink isn't going to backhaul it somewhere else to Atlanta or something?
The goal is to put in enough ground stations where every major data center will be tied into the Starlink satellite network. And now that they're putting in the satellites with satellites that have satellite to satellite lasers, their direct line of sight, they're not going to follow the curvature of the Earth. But if I want to get a hold of Microsoft.com, and there's a local mirror at that data center because it's a very large data center, why should I go all the way out to Washington State? And I'm going to go to Washington State over the internet backbone to get there? Through how many switches?
Obviously, it's that background that makes me think about the satellite delay, but I didn't realize that the mirroring was that extensive.
Oh yes.
So I'm really not. So so when I go to news.google.com or something like that.
No, you're not going to google.com. No. You're going to a mirror site that Google pays to have their content redistributed.
Holy cow! Then that has to be updated constantly, obviously.
Continuously, yes.
Okay. Wow. Well, I was just considering the speed of light is pretty quick, and that was enough to. But obviously, the speed of light is way too slow to go to Washington, right? So it needs to.
Well, it's not the
mirrored in Miami.
It's not the speed of light per se. It's all of the switching hops you have to make.
Now
So there is not a dedicated fiber optic cable from your neighborhood switching center to the Microsoft data center in Washington.
Well, thank goodness. It's very relieving to know that all the porn in the world, you don't have to go to a remote site. It's distributed somewhere near you.
Yes, yes.
Now, they're talking all about this infrastructure that they're supposed to be at. This is not infrastructure they're going to look at. They're going to look at concrete infrastructure rather than...
No, this is a part of it.
Oh, it is? That's a good thing.
When the original infrastructure bill was proposed, it included internet backbone upgrades, local internet distribution upgrades, things that the government would take away from the revenue stream of private industry. And private industry didn't like that at all. So when they first remodeled the infrastructure bill, it took out all of that, technology communications funding. And people were, the people were saying, but I've got a problem. I live in a neighborhood that AT&T will not run fiber to my house. So how am I supposed to get my broadband? There are places that still have DSL running at 1 megabit. And how is that household ever supposed to do any multimedia whatsoever? Well, by having an infrastructure assistance program that will subsidize getting the extension of the infrastructure into these less served neighborhoods. And, what's the easier way to do that? Satellite flying over your house. As opposed to, we got to run poles to your neighborhood and then a switching center and bury stuff in the ground by local subdivision edict. And, that's like real work. Much easier just to have everybody that want it, go spend $500 with SpaceX, and that price is going to be coming down over time. Go spend $500 with SpaceX and then $100 a month, and you get your 150 megabits of satellite connection.
Are there going to be those satellites also? I imagine they're not going to be equidistant all over because there aren't people all over. But there aren't the same number of people. But a huge problem with the internet that people have is in places out west where they have small towns or communities and stuff. As you know, I used to go out and install internet equipment in little areas for that distribution. And in fact, every time there's a Democratic administration in place, they want to spend the money to make sure every kid in America can get good internet. And then when there's a Republican administration, they say, no way, you should pay $10 to get a letter delivered in Montana because you live in Montana, and you shouldn't have good internet. And then Montana votes for the Republicans. But nonetheless, are these satellites going to bring broadband internet across the western United States and rural areas as well?
They're already serving those rural areas, and they're not serving my house because I'm not considered in critical need of it yet. So you can already get your Starlink satellite service out in the middle of Nebraska, but you can't get it in Fort Lauderdale.
I couldn't even get them to get AT&T to get to my house. It was just DSL. They couldn't do anything else to here. Well, actually, I had dial-up with AT&T. I had to go to Comcast, and Comcast gave me a hard time for 2 years because then they wouldn't come out, and then finally they did. They didn't want to come out because all I have around me is cows, you know. So they don't say the cows won't use the phone, daughter. So I taught a couple cows. No, but anyway,
here's the thing. Here's the thing. If your connection to the internet is terrestrial, meaning it's a wire hooked up to your house, then all the infrastructure to get to your house, regardless of however many other people there are on the block or in the neighborhood or for miles, all that has to be laid out there, and that costs money. And if you do that over a couple of millions of people that are out in the middle of nowhere, that's a lot of money for infrastructure that you're never going to get it back off of those few accounts. But if you orbit a satellite and the satellite goes over both metropolitan and rural areas, then you're servicing both communities with no additional cost. So by putting up a satellite constellation network, you can literally serve anybody anywhere on the planet, whether they're in a metropolitan area or whether they're in an urban or a rural area, or out in the middle of a third world, country that has no infrastructure. And the idea of it being a good number of 100 megabits, like 120 to 150 megabits as opposed to gigabit, is you can share that more easily because the satellites only have a certain amount of bandwidth. So if the satellites are gigabit and you're only delivering 150 megabits to a handful of people as you zoom over an area, then you can easily supply that all day long. But if you happen to fly over a place out in the middle of South America or Saharan Africa, you can put up one Starlink terminal with a switch and a router and serve 100 different people. And if they don't overload it, they'll have 150 megabits of bandwidth to share amongst themselves as soon as they can get that antenna up and running. So I think it's a good thing, obviously. But I'm also ticked that, between Comcast and AT&T, they took the better part of 10 years to get broadband to my house because nobody wanted to spend the money. And then when they did put it in, they begrudgingly put in 1 to 4 hours worth of battery backup. So even if I put UPS on my house or a generator at my house, if I'm going over their fiber or their wired network and a hurricane comes through, after 4 hours, I have no service. So I went to the next hop out, which is my internet service that I'm using right now to talk to you is over a fixed location 4G wireless connection. So I'm getting about 6 megabits to the local cell tower. Now, since there's money to be made off of the hundreds of people constantly using that cell tower, they have a diesel generator there, and they'll refuel it if the need be. So I should have internet access as long as I provide my own power, even while everybody else in my neighborhood that's on fiber or Comcast cable have no internet service. So that's why I'm interested in Starlink, is because it takes me to the next level where I'm not even dependent upon the local cell tower.
And that should happen soon?
I'm thinking when they go out of their beta mode and they start opening it up to the general public, months ago, I paid my $100 down deposit. So I'm expecting sometime in early October, fingers crossed, for me to receive my email notification. My house location is already identified. I already have an account with SpaceX Starlink. I've already paid my $100 deposit for my service connection. And I'm just waiting on them to say, okay, you pay us for the terminal and you can have your Starlink.
So
I'm
how
ready.
much is it going to cost you more for service, or?
Yeah, it's going to cost me $500 for the terminal, but those prices are coming down. They're currently going from a first generation to a second generation terminal, which should be cheaper and higher volume production. And when they do that, I'm hoping that $500 becomes maybe $300. But for it to be just a problem solved, I'm fine with the $500 because right now AT&T, given that, they don't know what they want to do with 5G. Do they want to sell that off? Do they want to maintain it?
Yeah.
Do they want to cut people back? Do they want to force everyone off of 4G onto 5G? Well, if they force me from 4G to 5G, it's going to cost me anywhere from $600 to $1,200 for a new 5G router.
Yeah.
So
This is a one-time fee, the $500, or is that a month? That's a one-time fee.
The dish and terminal router fee is $500 one time. The monthly cost is $100, but I'm right now spending over $200 a month with AT&T for all my communication services. So that should come down in cost.
You won't keep AT&T once they get you up and running.
I will maybe keep AT&T for my mobile phone and my computer mobile 4G connection, and that's it. I mean, I got off of Comcast over a year ago, and all my video services are now independently streaming. And I'm about to get rid of, if you remember, AT&T sold its video services out to DirecTV. And DirecTV is changing their policy and they want to up their monthly fee. And I'm just going to say, I don't need you anymore. And I'm actually going to change from the free YouTube service to the $12 a month YouTube Red service so I don't have any commercials. I subscribe to Peacock because it's free. I subscribe to Tubi because it's free. Hulu just went up $1 a month in their cost, but they're still cheap to keep. I get my Amazon Prime video service for free because I pay for my Prime because I buy everything on Amazon. My shipping costs are much less than if I, went to non-Amazon and paid for shipping.
Especially when you get it 3 times a week.
At least 3 times a week, yes.
You said you were cutting down.
It's still in the back of my head. I've got this. Why don't I have my groceries delivered? Because then you'd never leave home.
Yes, that's right.
I left home today. I haven't left the house in a week. I left home today to go to Dollar General to pick up my regular consumables and come back home. And I looked at the gas gauge and went, I've got 65 miles left in the tank. I'm not going to go to the gas station today. I'll go to the gas station next week.
Yeah, it's over $3 a gallon now.
Yeah, it's going up because so many people are at home. They're not buying gas, and the gas companies still want to make their billions in profit. So the cost per gallon's got to go up to make sure they keep the billions going.
Yeah, let Amazon do it.
Well, I got to tell you, I am thinking as soon as used Teslas start coming down in price, get myself an electric vehicle. But you know what happened recently? Because of the demand for Tesla vehicles and the fact that they've completely sold out their production for the rest of 2021, the price of used Teslas is now higher than the price of new Teslas.
Oh
That's
my
crazy.
gosh.
You think GM, Chrysler, or Ford ever had a day when used vehicles cost more than new? They'd never sell another new car. But there's such a demand for Tesla at this point, in particular the Model S Plaid, that you want to go buy yourself a Tesla Model S, buy a used one. They're available, but they're going to cost you more than if you wait in line until next year and get yourself a cheaper one, with a delay.
Well, the thing is to buy 5 of them.
Well, there are people out there buying 2 and 3 of them that have money, and they look at it as, I can buy a Tesla Model S Plaid, one of the fastest production cars on the planet, for, depending upon options, between $120,000 and $150,000. Or I can go buy myself a McLaren, which, too bad a Tesla Model S Plaid now beats it, for $200,000. So the guy that buys himself a Tesla Model S Plaid is actually saving about $50,000. So, yeah, Tesla is definitely doing a paradigm shift on the auto industry right now, and it's not going to be pretty.
How long does a Tesla last?
Well, there's still people out there driving them 18 years later.
18 years. Okay. That's pretty good.
Well, they don't have an internal combustion engine in them that clocks out after 200,000 miles. Tesla is now saying, as long as our battery management manages the rapid charge and rapid depletion of the power from the lithium batteries, the cars might last 1 million miles. You might need brakes occasionally, but they're working on that too, with regenerative braking. So there's going to be a different beast out there. It'll be about as chaotic as when horses went away and people were driving internal combustion cars. But horses are still out there. And I think that internal combustion engines will be an expensive niche thing for people that are into it for whatever reason. I mean, there's still people that listen to vinyl records instead of playing digital downloads.
They're coming back, vinyl.
They're coming back because somebody wants to charge you several $100s for a turntable.
But it plugs into the
USB, yes. And you no longer have a needle that's going to wear down the plastic of your records. It actually shines a laser beam on the grooves and picks up the vibrations via laser beam.
Oh, man. That's sacrilegious.
No. It actually improves the tonal sweetness of the sound because they rationalized that the needle pickup had a certain oscillating vibration in it, that if you get way up enough in that digital digitization of the signal, you can see it, but you won't see it with the laser.
Does it sound better?
They say the sound is sweeter, but then I'm more than 40 years old and my hearing is not what it once was, and I spent way too much time in computer rooms. So I'm going to say I'm fine with streaming audio.
I would say that too.
Okay.
They say turntables are still around because DJs use them. So you can still buy a turntable if you've got vinyl.
I have a lot of vinyl at home. Someday I'm hoping they'll be worth something.
We are after the midnight hour now.
I was just going to say.
Yeah. That'll be next week's subject. How much is vinyl worth now?
Pumpkin time.
Stella, how did you get a still shot for your picture? Is that Sally who has the cat picture?
That's Joanne's the cat picture, and you just have to go in. You just have to go into your Zoom account settings and give yourself a personal photo.
I don't have.
But you also have to join Zoom somehow. That's how I had to do in order to get a picture. Okay. Maybe Sally knows a different way, but that's how I had to do it.
Okay.
But it doesn't cost anything. It was free.
Oh no, it doesn't cost anything. The Zoom account's free and it's easy enough to upload. Let me show you something here. If I turn off,
you join other than putting your picture up, what are your benefits?
Well, you can hide yourself. So if I go in here, where's my
actually have
video?
a meeting. You could have a meeting and it wouldn't cost you anything, as long as you don't. There's a limit on how many meetings you can have a month.
No. Zoom has a limit of 43 minutes. If they're not busy, then you can go longer than that. But if you want to do multi-hour sessions like this, it's $15 a month. But if you want to have personal Zoom sessions from one computer to another, and you keep it to less than 45 minutes, Zoom is essentially free.
Yeah. So there are a lot of benefits if you want to utilize them.
Right.
Okay.
So if I stop my video and then I talk, you should see that my picture is actually the Broward Astronomy logo.
Right. Yeah.
The BA turned on its side. So you can
I
use
have
it.
to ask, how many people see that as BOX? Because I cannot help seeing BOX. I know it's BA. Okay.
Do you remember those psychological images where it looks like it's two people or it's a vase? It's the same sort of thing. I deliberately chose that logo for a number of reasons.
Okay.
It's also a stylized baby owl because it's educational. It looks like two little round eyes, the eyebrows of the owl, and then a round belly for the owl, and then it's 2 feet.
Yeah.
Oh, okay.
So it looks like a cute little baby owl. But what it actually is, turned 90 degrees, it is a lowercase beta and a lowercase alpha, B-A. And then I adjusted the kerning so that the two letters actually overlap slightly to make a contiguous surface.
Yeah.
And then I reduced it from 16 million colors to just black and white. So it makes a really great logo.
Yeah, it's very elegant. I love it.
Yeah.
Yes.
Oh,
I like it too.
if you read to the bottom of the email that I sent around today, you remember me mentioning last week that I wanted to find a way to monetize YouTube? And I did. I've created, not related to Broward Astronomy, a new YouTube site called Not Waiting. I actually found that to be available. So I've got a logo that I've done for that. That's NW turned 90 degrees. It looks springy like my waveform. The Not Waiting will be the home for my soapbox rants. This is basically. So when I want to discuss, for example, there's a shortage of computer chips and therefore you can't buy cars. But you can certainly go to your local cell phone store and buy any phone you want. And they have computer chips in every one of those. Huh.
Yeah.
How does that work? I'm sure there's a lot more phones that need to be manufactured than cars. So,
How did you monetize it then?
There is a guy on YouTube that goes under the name Veritasium. His name is Derek. And he's been out there for more than 10 years. He understands the YouTube formula. And you have to have your video be between 8.5 and 10 minutes long. You have to have it be a very quick, digestible thing. You don't have a lot of text slides or anything. It's just you monologuing, staring into the camera, blathering on about something that you got to be very succinct to get across the moment. And then you give it a punchy title, like, What's Up with Helium? And you put it out there as public, and then YouTube wants to put their advertisements wherever eyeballs go. So if you're a venomous voice and you have all these punched up titles, you become what is known as clickbait. you start showing up under people's YouTube view, and you click on a video and you watch it and you go, oh, that was interesting. And then you find another one by the same person, you go, oh, that's interesting. The YouTube formula sees this and goes, okay, because it's more than 8 minutes long, we're going to inject an advertisement that you have no choice in the matter. We're going to inject an advertisement in at about 6 minutes. And then if you go beyond 12 minutes, we'll inject another advertisement at about 11 minutes. And when they inject these advertisements, if you've checked the box and set up a YouTube account that says, I want to monetize this, YouTube will give you a thin slice of the action for all those commercials. And if all of a sudden you find a topic like, stop looking for ET, something simple that really grabs people's attention, and then you explain why looking for ET probably doesn't make sense, they'll be here next Thursday anyway. If you do something like that, and all of a sudden it cracks out and you get, 500,000 views, if that tends to be at the end of a month or end of a quarter, the advertisers have budget money left over, and they will dump residual budget money for advertisements into YouTube, and then YouTube will just shotgun blast to all of the most popular feeds advertisements. So you'll start, for every view, you'll get another 3 cents. And if it's, 500,000 views, and you do this over an inventory of 5 or 10 videos, they're there forever. The ads rotate through in different ads. So you can create yourself a monetary stream from YouTube. It's not a lot, but if you keep pumping out those videos and you keep, getting titles that people want to click on, and you keep lining up your thought pattern with that, outrageous 10% of the public, they're going to see your ads, you're going to make money. It's not going to be huge, but there are people out there that are making several $1,000s a month off of, 10 years worth of videos that people are still watching. But I don't want to do that with Broward Astronomy, because converting a 2-hour session to, 8.5 minutes of clickbait is just not satisfying for our audience. So I'll split it off and we'll have 2 sites. But I do recommend a couple of folks on YouTube, Veritasium and Physics Girl and Dr. Becky. And what I found out last week, Helen pointed this out, we're still on Facebook Live right now, and there's nobody there but me. I guess Helen wasn't here to publicize it, so nobody joined. But Facebook, after your session is over, goes back through your chat. And if there are any commercial sites as hyperlinks in your chat, Facebook removes them from your chat, because Facebook doesn't want you monetizing your Facebook Live session when they'd rather you spend advertisement money with Facebook. So, anywho. All right, then. I guess we're done for tonight. Thanks, everyone. Yeah.
Sure was fun. Thank you.
We'll talk again next week. Good night, all.
Good night.
Good night.
Night.